The whole chapter is called together. This is 10.1. You are correct. Factoring common monomials. Basically, guys, do you remember factoring?
Nope.
Yeah, bingo. Greatest common factor. Good job. That's what we're doing today. But we're doing it with monomials. All right. The GCF of a polynomial is the product. What does product mean? That's right. Good job. Of all factors shared. Franz, you're supposed to be writing your notes. By every term of the polynomial. Okay. The greatest common factor of a polynomial is the product, there's a key word there, product, of all factors shared by every term of the polynomial. Now, if all you heard was wah, 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 I'm going to be giving you examples in a minute. But you definitely need to have this written down. You better hurry. Relatively prime. You guys have learned this, but just in case you have no idea what I'm talking about, it's when two numbers or terms, in this case, have a greatest common factor of 1 only. So the greatest common factor is 1. Like, I guess, 3 and 2. The only number they share, the only factor they have in common would be 1. So they would be relatively prime. Now keep in mind, as far as factors, those are numbers that go into the number, can be divided by. Like 10. 1 can go into 10, 2 can go into 10, 5 can go into 10, and 10 can go into 10. Those are factors. Okay, multiples are like 10, 20, 30, etc. All right, so in 6, what would be the factors of 6?
1, 2, 3, and 6.
There you go. 1 can go into 6, 2 can go into 6, and it's evenly, by the way. 3 can go into 6, and 6 can go into 6. But greatest common factor is between like two numbers. Okay? 2 and 6. Greatest common factor would be 2. Because 2 goes into 2 and 2 goes into 6. But if you were to compare 2 and 3, the greatest common factor would be 1, therefore it's relatively prime. Any questions? Again, this is all review for y'all. All right, so step 1, find the greatest common factor of all terms. Step 2, divide the greatest common factor out of each term. Sort of like reverse distributive. property. Sort of. And I'm going to give y'all lots of examples on this. By the time I'm done, you'll be able to do this in your sleep. All right, step 3, write the factorization as, this is how you write it, GCF times the sum of quotients. And again, don't freak out. Like, what is she talking about? I'm going to show you a bunch of examples. I won't leave y'all hanging. Blair, you don't have a spiral?
Yes.
Why don't you write your notes in spiral? Okay. Keep writing. You have it? You good? All right. Open up your books. We're doing examples. Page 406. Don't lose that paper then, Blair, okay? Everyone have their books open? Wake up, Ariel. Okay, be ready, because I have a lot of examples. Like, a lot. Did I mention I have a lot? All right, here we go. And I don't know why I have them all out of order. Don't know why.
I'm sure you have logical explanation.
I'm sure one time I did, but like for 2 or 3 years in a row, they're all out of order. So now I can't remember why. That's okay. We're going to go in order this time. And it's probably going to, I will regret it. That's okay. I should write notes and say, this is why we're doing it out of order. All right.
Your future self.
Exactly. All right, so the first part for number 1, we're doing number 1 together. Everyone. It says find the GCF. If the GCF is 1, then you write relatively prime. So number 1 is 45 and 75. Okay. Who remembers what do we do? Chat.
The factor trees.
Oh, the factor trees. Okay, which 2 numbers? When multiplied, give me 45. Anyone. Chat. 9 times 5. Is 9 prime, boys and girls? No. Is 5 prime?
Yes.
Yeah. So what does Miss Rogers do? She circles it.
Mm-hmm.
What 2 numbers when multiplied? Give me 9. 3 times 3. Is 3 prime?
Yes.
Yes. So we circle the 3's. Now let's go over here to 75. Franz, what 2 numbers when multiplied? Give
5
me.
and 15.
You are so smart. 5 times 15.
5 is a prime number, circle it.
And 15 goes into 3 and 5.
3 times 5, because 15 is not prime. Is 3 prime?
Yes.
Circle it. Is 5 prime?
Yes.
Circle it. Now, if you remember, down here, we're going to write the factors out for 45. These are the prime factors, not the factors, but prime factors. And we do it in order. 3 times 3, and I'm crossing it out so I don't make mistakes, times 5. Now for 75. 3, cross it out, times 5, cross it out, times 5, cross it out. Now, who wants to tell me what to do? Franz, what do I do?
Circle is 3 from the 4, 5, and circle.
Your pairs, right?
Yeah, pairs.
Circle our pairs. I have a pair here, and I have a pair here.
So 3 times 5.
Right? You circle your pairs. Bring those down, and you only write them one time. 3 times 5 equals
15.
15 is our greatest common factor. Very good. Do y'all remember this now? If not, I hope it's coming back. Okay. Wait till everyone has it down. Valeria, you got it? Those of you in the back, y'all got it? Any questions so far? None? Oh, good. That means you all remember everything. Let's do number 5. We're still doing the same thing. Oh no, there's letters. I have x squared y cubed and x cubed y squared. Now this one, if you remember correctly, and don't freak out if you don't remember, okay, hopefully it all comes back. But if you do remember, do we have to do a factor tree for letters? No, we do not. We just, over here, I'm going to write down this term, and we write out how many x's do we have here?
2.
I heard someone say 2. Very good. And we write them out with multiplication. How many y's do I have? That's right. I hear someone whispering 3, 2. Okay. And notice I'm multiplying them all together. Now I'm going to write this next term down. Do the same thing. How many x's do I have in the next one?
3.
I have 3. And how many y's?
2.
Very good. And just like Franz did in the other one, we circle our pairs. I have a pair here, a pair here, I have a pair here and here. It doesn't matter which ones as long as you're doing a pair. You write it only once each pair while multiplying. Ariel, how many x's do I have?
2.
Very good. And Keith, how many y's do I have?
2.
There's your greatest common factor for those terms. Any questions? None? All right. So I guess you know that. Why didn't I do others? Hold on. What? Pi. Where's that at? I'm not there. Oh, it's just looked at as like a letter, a variable. That's it. Okay. I'm going to do an easy one. Let's look at 7. This is what you're doing today. So it says factor. You're going to factor the polynomial. I'm going to show you one example of an easy one, and then you're going to be like, oh, that's it? Literally. Okay, so 7 is 3x plus 3y. Boys and girls, I want you to look at that. Here's a term, here's a term. What do they both have in common?
They're all prime.
What, Morgan?
3.
3. So let's take it out. What do we have left, Morgan?
X, Y.
X what?
X times Y.
What?
X plus Y.
There you go. And there's the answer. That's what you are doing today. So you're looking at the terms. You take out what they have in common, and it's the greatest common factor. And they both have just 3 in common, so you're removing it, and you're writing down what is left.
It's just unsimplifying.
It's basically doing, like I put in the notes, you're doing backwards distributed property. Because look, if I were to do distributed property, I'd come up with this. Right? That's actually how you can check yourself. Is once you get the answer, check. Let's do 9. I don't know why I didn't do these last year. 8x minus, 32y. Okay, so Sophia, what do both of these terms have in common? So they both can be divided by 8. Now let me ask you, what if she said 2? Do they both have 2 in common? Right? Ariel, are you paying attention? Do they both have 2 in common? Okay, but is that the greatest common factor? Is that the biggest number that can go into both? No. So Sophia is correct. 8 is the largest number that can go into both. And there's not a letter because they both don't have any letter in common. So we take the 8 out, and we're left with x minus y. Any questions?
It couldn't be negative 8 because that's a really low number.
Correct. Are there any questions so far? Yes.
How would you check yourself with that?
What's 8 times x?
8x.
What's 8 times negative y? Oh, I messed up. Ooh, I messed up. Oh, boy, thank you. Oh, I messed up. You can't just take 8 out. 8 comes out, but 8 divided by 8 is 1. That's why this is here. Oh, I'm so sorry. What is 32 divided by 8?
4.
There we go. That's the correct answer. Do not listen to me. Listen to chat.
Yeah.
Catching me when I make a mistake. Does that make more sense now?
Yeah, I was
Yeah.
like.
This makes more sense.
What happened to the 32?
Exactly. So it's 32. How many times? So greatest common factor is 8. How many times is 8 going to 8? 1 time, or invisible 1. 32 divided by 8 is 4. Does that make more sense? Hopefully, yes. Let's look at 13. Have x squared y plus wz. Ariel, what do they have in common?
Nothing.
Bingo. So what do we write?
X squared y times y plus.
If they have nothing in common,
Oh, you would write prime.
thank you. If they have nothing in common. All right. Y'all ready for another one? Let's look at 15. 7x, and I promise not to mess this one up. 7x squared minus 49xy plus 28 y squared. Okay. See, Miranda's probably watching this just laughing and rolling her eyes. Okay. I'm going to pick on new. What is the largest number and or letter that you can take out of each term? That's right. Are there any letters? No, you're right, because there's an x here, x squared to be exact, x, y, and a y squared. So do y'all see that? That all three terms have to have the same thing, or at least one of them, you know, and they don't. So just 7 comes out. So 7x squared divided by 7, what do I have left? I pulled the 7 out. What do I have left new? X squared minus, what's 49 divided by 7? 7 xy, because we didn't take any letter out. And 28 divided by 7, 4, and we have y squared because we didn't take any letters out. Does that look okay? And again, if you want to put that 1 there because 7 divided by 7 is 1, absolutely can do that. It's not wrong. I say it's not. Do what? Right. I know. It looks odd to me too, but some people feel more comfortable with the 1 there, you know, so it's, Chap is saying yes.
I have a question.
Yes, sir. Did I mess up somewhere?
No.
Okay.
Can you give us an example where you would take out like an X?
Oh yeah, I'll get to it. Okay, does everyone have this? Blair, you got it on your piece of paper? Okay, good. All right, let's see. I don't know why. I still can't figure out why these are all out of order. Okay, let's look at 17. I told you I'm doing a whole bunch. Clearly I need it too. 6a squared plus 48a minus 24. Keith, what can I pull out of all three of those? Good. And what am I left with?
A squared plus 8a minus 4.
Perfect. 6 divided by 6 is 1. And if you feel better, you can put a little 1 there. 48a divided by just 6 is 8a. Negative 24 divided by 6 is negative 4. Any questions? Do we feel a little comfortable now to move on to some letters? Okay. 19. All right, chap, you ready? I have 6a squared b plus 3ab squared. All right, chap, you're my victim. Now first, let's look at the numbers. I have a 6 and a 3, so what's the largest number that can go into both? Perfect. Now, chap, are y'all watching? Everyone better watch. I have an a squared and an a. What is the largest that can go into both?
A and B?
Let's start with the a.
Okay. So just 1A.
1a, because a squared can't go into that. Remember, we're taking greatest common factor. And then we have a b on this side and a b squared over here. So what would you take?
B.
B. Does everyone see that? Okay. Now, chap, what am I left with?
2A.
Because, okay, do y'all see what he did? 6 divided by 3 is 2. A squared divided by a. Remember, we subtract exponents. So that'd be 2 minus 1. That's going to give us 1. And then b1 minus 1, that's b to the 0. which is really just 1. So they kind of like cancel out. And then what would this be, chat?
B.
Just B, because 3 divided by 3 is 1. We don't have to put a 1 there. A divided by A is just another 1. B squared divided by B, and remember, that's like a little 1. That would be 2 minus 1 equals B. And you can even say 1, I don't care. And there's your answer. Now, again, to check yourself, you can go back and do the distributive property. 3AB times 2A, that would be 3 times 2 is 6. A times A is A squared, and then B is just B. And then 3AB times B is 3AB squared. So definitely you can check yourself each time. Are there any questions about this? If y'all don't tell me you have a question, can't help you. Don't be embarrassed either. I got all day long. I mean, not really, but I love doing that. So, all right, let's do 21. See, I told you I'm going to do a lot. All right, again, we're still doing factoring polynomials. I don't know why they give the same direction. Oh, it's section B. All right, 91. A cubed B squared, oh, it's getting harder, plus 13A squared B. All right, if you're sitting there, because the others we did were quite easy, a 6 and a 3, come on, those are easy. If you're sitting here saying, I don't know what number, then what do? Off to the side, you do your 91, you do your factor tree, and your 13, and do your factor tree. So let's just look at this. 13. It's prime, correct? So check how many, can 13 go into 91? If 13's prime, then quite possibly, since your math book is giving you this, can 13 go into 91, boys and girls? Okay, Valeria isn't saying anything. She's quietly sitting there showing me fingers. All right, so yes. So what can we take out of 91A cubed B squared and 13A squared B? Morgan.
13.
We can take the number 13 out of 91 and 13. And then what about the A cubed and the A squared? What's the largest we can take out?
A2.
A squared, or A to the power of 2. Do y'all see that? That's the largest we can take out of both of those.
You can't take out a B.
Well, I'm not there yet. Okay, Morgan, B squared and regular B, what's the largest?
B1.
B1, that's right. And we can even put that, unless that confuses you. So, Morgan, 91 divided by 13 is?
5? Was it 5? 3.
Why don't you write it out?
7.
7.
Keith, quit yelling out answers. All right. A cubed divided by A squared, Morgan. A cubed divided by A to the power 1. B squared divided by B.
B.
Plus 13 divided by 13.
1.
A squared divided by A squared.
0.
1.
I know, no, but like the
Okay.
exponent is
So
0.
then what do I put here?
You can put a 1 if you want.
That's what you're
but,
supposed to. That's the answer.
Oh, because the B cancels out as well. I see. I didn't see
Yep.
that.
13. That's why those of you that want to put like up here, if you want to put 3 divided by 3 is 1, if you want to put those 1s in there, by all means. Because that could be your answer. So if you're not sure, again, go back and do distributed property. If you look, 13A squared B times 1, it's going to give you the same thing. Y'all see that? Sophia, do you see it? All right, good. Let's look at 23. 14x squared y minus 15z. Sophia, what can we take out of those two terms? So then it is? Very good, it's prime. All right, let's look at another one. 25. I have 12x cubed minus 16xy squared. Ariel, what can I take out of both? What? 4? Okay, so looking at the numbers, 4 can come out of them. That's the greatest number. And is there any letter?
X squared.
Can x squared come out of this?
No, so it's just X.
There you go. It's just x. Good job. And there's not a y over here, so I can't take y out.
Yeah.
Good. So 12 divided by 4 is what, Ariel? And then x cubed divided by x is?
X squared.
Good job. Minus, what's 16 divided by 4?
4.
And then x divided by x is?
0.
Or,
Or X to this 0.
which is?
Which is just 1.
Yeah, so we don't even need to put that there. And then y squared divided by nothing is just y squared. And again, if you want to check, do distributive property. 4x times 3x squared is 12x cubed minus 4 times 4 is 16. X times nothing is x. And nothing times y squared is y squared. Any questions? Y'all are actually doing better than last year's group. Any questions? 29. 7a to the 5th minus 84a cubed plus 21a. Keith, you love answering. What is the biggest number that I can take out of all these?
7.
There you go. Is there a letter that I can take out of all three?
Yeah, I know. A.
Very good. Because this is a to the 5th, a to the 3rd, and just plain old a. So just a plain old a to the 1 power is the largest that we can take out of there. So 7 divided by 7 is what? I'm going to go ahead and put a 1 so that everyone's happy. A to the 5th divided by a1 is what?
Wait, what?
A to the 5th divided by a to the 4th, because again we're subtracting exponents, good. Minus, what's 84 divided by 7? 12. A cubed divided by a1. A squared plus 21 divided by 7, Keith? And a divided by a is, they cancel out. So there's my answer. Any questions? All right, let's look at 2 more. So I think you've got it. 2 more. Now these are weird. I didn't teach it to you in the notes because I want to show you 2 examples. Y'all ready? Look at 31. Whoops. I can't even write that. 31. That's 31. All right, notice it's different. It doesn't look like the others. X times x minus 2 plus 8 times 8x minus 2. It's because I didn't eat lunch. All right, now, new, to keep you awake. This is a whole, let's say, term, and this is a whole term. What do they both have in common? Bingo. Do y'all see that? They have x minus 2 in common, so I take it out. Times, what do I have left over, New? X plus 8. There's your answer. Why? Aren't these the same? Are they the same? Then you just pull that out, and you're left with x plus 8. Y'all see that? Let me tell you something. If you do a distributed property, you're going to start getting something ugly. All right, so let's say I want to pull that out. That'd be x squared minus 2x, right? Plus 8x minus 16. You see where I'm going with this? So wouldn't it be easier just to do that? Yes, it would be. All right, let's do one more. I'm going to do it on the back side. Look at 33. 5 times b plus c, Franz, you're my victim, plus a times b plus c. Franz, what do they have in common?
The B
Just the b?
and C.
Okay, give me specifics. What do they have in common? Look at both terms. Look up here. Look up here. What do they both have in common? Don't just say B and C. What exactly?
B plus C.
Bingo. B plus C. So I'm going to pull that out. Times, because we're pulling it out. 5 plus A. You have this written down? Any questions?
I understand.
Y'all ready to be set free? All right. Don't even worry about it. Page 406 to 407. All right. Numbers. Hold on. Oh, yeah. No. Ooh-wee. That's right. I'm challenging. All right. 16 through 34 even. Honors. 20 to 34 even. And 40 and 42. Ooh. It's due Tuesday. I believe I've got you scheduled. I gotta see. Scheduled for a quiz on Friday. So we're gonna end our week with a quiz.
So kind
And IXL, which I have not assigned, which I will do in just a second, it will also be due Friday. All right.
How much